Limestone is used in the steel industry, ornamental stone, chemical and optical uses as a mineral specimen. Calcium sulfide with half a molecule of water per molecule of salt is called plaster of Paris, means hemihydrate. Cement is an important building material. It also called as Portland cement. Magnesium plays a role in the stability of all polyphosphate compounds in the cells, including those associated with DNA and RNA synthesis. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Today we are starting up session 5 from the chapter S block elements. In the last session, we have discussed about general characteristics of compounds of the alkaline earth metals, oxides and hydroxides and halides. These topics we have discussed in the previous session. In this session, we will discuss about calcium hydroxide, calcium carbonate, plaster of Paris, cement and biological role of magnesium and calcium. These are the contents we are discussing in this session. First one, calcium hydroxide, that is slaked lime. How it will be prepared? The preparation: on adding water, quick lime forms slaked lime. Calcium oxide, when treated with water, it will form slaked lime. Slaked lime is a white amorphous solid. The aqueous solution of slaked lime is called lime water. The suspension of slaked lime in water is called milk of lime. Means it is a white amorphous solid. When it has been treated with water, little bit thick solution will be remain in the bottom and the aqueous solution will be called lime water and the suspension will be called it as milk of lime. Chemical properties: when carbon dioxide is passed through lime water, it turns milky due to the formation of calcium carbonate. When calcium hydroxide treated with carbon dioxide, it will form calcium carbonate with water. By passing excess of carbon dioxide, the precipitate dissolves to form calcium hydrogen carbonate. Means when calcium carbonate treated with excessive carbon dioxide with and water, it will form calcium bicarbonate. Next one, milk of lime, that is the suspension. Milk of lime reacts with chlorine to form hypochlorite, a constituent of bleaching powder. When calcium hydroxide treating with chlorine, it will form calcium chloride and calcium hypochlorite with water. This is the constituent for bleaching powder. Next, uses. How the calcium hydroxide will be used? In the preparation of mortar, a building material. In the laboratory, mortar and pestle you have seen. That mortar or pestle will be prepared by calcium hydroxide. In whitewash, due to the disinfectant nature. In glass making, tanning industry, in the preparation of bleaching powder and for the purification of sugar. You know, like detergent like bleaching powder, the toilet cleaners you have seen for that purpose, and purification of sugar, the last method after the sugar manufacturing or preparation, purification has to done. For that purification, calcium hydroxide will be used. Next, calcium carbonate, limestone. Occurrence: calcium carbonate occurs in nature. It is estimated that about 4% of the earth's crust is made of calcium carbonate. The 4% of earth crust is made up of calcium carbonate. The calcium carbonate cycle is composed of rocks, minerals, water, plants and animals. It has been comprised of the inorganic materials also and organic materials also. It is found naturally as minerals and rocks, some of which include calcite, limestone, chalk, marble and aragonite. Minerals and rocks impart calcium carbonate in natural water sources, resulting in hard water. In fact, calcium bicarbonate is the main cause of water hardness. It is also a major constituent of compound of shells and skeletons of animal. It is present 4% in the earth crust. It comprised of organic material also, inorganic material also, and if it is present in water, that will result in the hardness of water. Not only the external area, within our body also, in our teeth, in bones like skeletons, calcium is very much needed. Next, preparation. Calcium carbonate is prepared by adding water to calcium oxide. When calcium oxide is treated with water, obviously it will form calcium hydroxide. When calcium hydroxide treated with carbon dioxide will be, that calcium carbonate will be formed. To get calcium hydroxide and carbon dioxide is passed through this solution, the precipitate of calcium carbonate is formed. Industrially it is called precipitated calcium carbonate. Next, uses of calcium carbonate. Calcium carbonate is mostly used in the construction industry as a building material such as limestone, marble or chalk. It can also be used as an ingredient of cement. When manufacturing of cement, this calcium carbonate will be used. Calcium carbonate in the form of chalk used in the filler in the paper industry, it is used as a cheap way to make bright opaque paper. It will be used in the manufacturing of paper or chalk also to get brightness over it. Limestone is used in the decoration and construction. The main use being its contribution to making a mortar. It is used in the bonding bricks, concrete blocks, stones and tiles. Whatever you are using nowadays, floor tiles or wall tiles, and also like stones which has been sculptured very nicely as a attractive way, for those things it will be used. Limestone is used in the steel industry, ornamental stone, chemical and optical uses as a mineral specimens. The limestone can also be used to make glasses also. It is also used as antacid, mild abrasive in toothpaste, a constituent of chewing gum and a filler in cosmetics. It is used in cosmetic industries also and medicine industries also. Next one, plaster of Paris. This plaster of Paris, you know that nowadays the false ceiling criteria you have been seen for the attractiveness, to enhance the attractiveness of the home, the people are making for false ceiling. That false ceiling will be done by this POP will be called. The POP is nothing but plaster of Paris. Preparation, properties and uses of plaster of Paris. Calcium sulfide with half a molecule of water per molecule of salt is called plaster of Paris, means hemihydrate. Preparation. Plaster of Paris is prepared by the heating gypsum, that is calcium sulfate bihydrate, that is hemihydrate, at 120 degrees Celsius in rotary kits where it gets partially dehydrated. See here, this is calcium sulfate dihydrate. At the 120 degrees Celsius, it will form calcium sulfate hemihydrate with 2 molecules will be removed. The temperature should be kept below 120 degrees Celsius, otherwise further dehydration will take place and the setting property of the plaster will be partially reduced. If it exceeds for temperature 120 degree, what all the setting property will be done for plaster of Paris? It will be not good. Above 120 degrees Celsius, no water of crystallization is left and anhydrous calcium sulfate is formed. It is known as dead burn plaster. Next properties. Plaster of Paris is a white powder. When mixed with water, it evolves heat and quickly sets to a hard porous mass within 5 to 15 minutes. During setting, a slight expansion in volume occurs so that it fills the mold completely and takes a sharp impression. The setting of the plaster of Paris is believed to be due to the rehydration and its reconversion into gypsum. Means when plaster of Paris is reacting with water, it will evolve some of the heat and quickly sets with a hard porous, okay, within 5 to 15 minutes. And whatever molds you will put, within that molds, if you use more volume of POP, it will set very nicely and after rehydration, it will be thick. The process of setting occurs as follows. This is plaster of Paris, treating with water, it will form gypsum, and when gypsum is hardening, it will also form that POP. The first step is called the setting stage and the second the hardening of stage. The setting of plaster of Paris is catalyzed by sodium chloride while it is reduced by borax or alum. Next, uses of POP in surgery for setting broken or fractured bones. Whenever you have met with an accident or if you fell down somewhere, the doctor will tell some ligament tear or bone little bit fractured. That time that white cement they will put, no, that is nothing but POP. For making cast for statues in dentistry, for surgical instruments and toys, etc. If you have been for the dentist clinic, they will show one teeth structure with a set that will be also done by POP with toys and so many statues like that. In making blackboard chalks, in construction industry, and note magnesium sulfate heptahydrate is commonly known as Epsom salt. That whatever we are using from calcium, that is gypsum. If it is magnesium, that is Epsom salt. Chemical formula MgSO4 heptahydrate. Next is cement. Cement is an important building material. It also called as Portland cement. For construction of houses or buildings, we will use this one. It is so called because it resembles with the natural limestone quarried in the Isle of Portland, England. The first occurrence of Portland cement came about in the 19th century. In 1824, Joseph Aspdin, a Leeds mason, took out a patent on a hydraulic cement that he coined Portland cement. He named it cement because it produced a concrete that resembled the color of the natural limestone quarried on the Isle of Portland, England. Today, Portland cement is the most widely used building material in the world. About 1.56 billion tons is produced each year. Means this Joseph discovered he gave the name and he told about the cement which resembles the limestone. But now, in our today's life, this cement is widely used in our nation or earth. Like 1.72 billion tons will be manufactured each year. Cement is a product obtained by combining a material rich in lime, calcium oxide with other material such as clay which contains silica oxide along with the oxides of aluminium, iron and magnesium. The average composition of Portland cement means the cement is not a one constituent, it is comprised of calcium oxide, this silicon oxide, aluminium oxide, magnesium oxide, iron oxide and this sulfates also with approximate composition 50 to 60%, this 20 to 25%, aluminium oxide 5 to 10%, magnesium oxide 3%, iron oxide 1 to 2% and sulfur trioxide 1 to 2% is present. This is the overall composition of or overall components of cement. For a good quality cement, the ratio of silica to aluminium should be between 2.4 and 4 and the ratio of lime to the total of the oxides of silicon, aluminium and iron should be as close as possible to 2. The raw materials for the manufacture of cement are limestone and clay. When clay and lime are strongly heated together, they fuse and react to form cement clinker. This clinker is mixed with 2 to 3% by weightage of gypsum to form cement. Important ingredients present in the Portland cement are dicalcium silicate 26%, tricalcium silicate 51% and tricalcium aluminate 11%. These are the main ingredients, but also whatever we have seen in the table, those are also the components of cement with its approximate percentage. Next, setting. Cement sets when mixed with water by a complex series of chemical reactions. Still only partly understood. When mixed with water, the setting of cement takes place to give hard mass. When it is reacting with oxygen or when it reacting with water, it will form liquid-like or jelly-like substance. But when it is left for some time, it will form hard mass. This is due to the hydration of the molecules of the constituents and their rearrangement. The purpose of adding gypsum is only to slow down the process of setting of the cement so that it gets sufficiently hardened. They will add the gypsum to delay the setting of cement. Next, uses of cement. Buildings means floor concretes and reinforced concretes, beams, columns, roofing, bricks, mortar, panels and plaster. Transportation in roads, pathways, crossings, bridges like that. Water, pipes, culverts, curbing, drains, canals. So many years back, they were using huge cement pipes, but nowadays they are changing to PVC pipes also. Civil, like piers, docks, retaining walls, warehousing, poles, pylons like that. Agriculture, buildings, processing, housing, feedlots, irrigation. There are major application of cement in the daily life. Next, the biological role of magnesium. Magnesium is an essential element in biological systems. Magnesium occurs typically as Mg2 plus ion. It is an essential mineral nutrient for life present in every cell of organism. Magnesium is very important for our life and it is an essential nutrient which is present in each cell of the organism. For example, ATP, that is adenosine triphosphate, the main source of energy in cells, must be bound to a magnesium ion in order to biologically active. The ATP, which is a source of energy, should be bound with magnesium in every cell to be active, or else it is not bounded with magnesium means that ATP will not be used. Magnesium plays a role in the stability of all polyphosphate compounds in the cells, including those associated with DNA and RNA synthesis. Over 300 enzymes require the presence of magnesium ions for their catalytic action, including all enzymes utilizing or synthesizing ATP or those that of other nucleotides to synthesize DNA and RNA. For enzyme action also, in the DNA and RNA synthesizing also, magnesium is very much essential. In plants, magnesium is an integral part of chlorophyll, a green pigment in plants responsible for photosynthesis. We know from the previous, in the lower classes, photosynthesis will be done by chlorophyll pigment in the chloroplast, but to run the photosynthesis, magnesium is also an integral part. A typical adult human being requires 200 to 300 mg of magnesium daily. Next one, biological role of calcium. Calcium is an essential element in living organisms. It plays an important role in the metabolism of nitrogen in some plants, where a deficiency of calcium leads to poor absorption of nitrogen. See here, one correlation is also there. When calcium is not present sufficiently in our body, it will not absorb nitrogen also. Lack of calcium in plant nutrition leads to reduction in the number and size of the chloroplast. When size of the chloroplast or number of chloroplasts should be sufficient in the plants, then the lack sufficient in the plants means the calcium should be enough amount in the plants. Calcium is the most abundant inorganic element in the higher animals and is located principally in the bones and teeth as appetite. A calcium phosphate mineral, blood is also a huge reservoir of calcium in animals. In bones, teeth, calcium is very much important. It is abundantly present. Calcium is distributed throughout all tissues where it has special roles in controlling nerve impulse, transmission, muscle action, blood clotting and cell permeability. For nerve impulse also calcium is required. For teeth and bones hardness also calcium is required. For plants also it is required to maintain the number of chloroplast and size of chloroplast. Next, calcium deficiency is exhibited by the onset of rickets, failures of the blood clotting mechanism, nervous disorders and convulsive muscular contractions. Vitamin D greatly improves the absorbability of calcium ion. Vitamin D treatment in rickets is based on this effect. Large intakes of calcium lead to excessive calcification and kidney stone. These are the major problems when the calcium is sufficiently not present in our body. Calcium absorption, vitamin D is also required. If it is not present, the rickets, calcification or kidney stones will be formed. Note, an adult body contains about 25 gram of magnesium, 1200 gram of calcium, 5 gram of iron and 0.06 gram of copper. These are the elemental properties should be present in an adult human being, or else it will turn up to rarely disease and there should be we have to suffer with some problems. This end up with S block elements with its atomic properties to application level and biological importance also we have seen. I hope you have completely understood all the sessions of this chapter. We'll meet in the next chapter. Thank you.